Welcome back to the build of my Rans S20. I know it's been a while since my last video, but I've been busy traveling and setting up the new shop. In my last video, I covered installing the engine. In this episode, I'm going to cover the engine electrical system because the Rotax 912IS is computer controlled and interfaces digitally with the rest of the airplane. Then I performed the all-important power and ground check of the entire electrical system before I turn the system on and configure the avionics. I'm also going to cover labeling the panel switches and finally covering the wings with fabric. This is where it starts to look complicated. I first snaked the engine electrical harness around the engine mount and hoses to the firewall mounted computer and relay box, and also mounting the miscellaneous sensors to the engine mounts. All the wires to the engine compartment were run through the firewall with two steel fire sleeve feed-throughs, which were also potted with fireproof sealant. There's no way any fire or smoke will get through those big holes. And because the feed-throughs were potted, I added a few spare shielded and single wires of various sizes. This will come in handy if I ever add components, although I already included wires for an electric prop, even though I'm initially going with a ground adjustable prop. Then I started to route them up into bundles, starting at the firewall, making sure that no wires would touch structure or be near a source of high heat. The spare wires were capped, labeled, and tied up in a conspicuous area so the next owner could easily find them. The engine interface uses these two Molex automotive connectors supplied with the Rotax engine. Honestly, they were a real pain to work with, as they were very delicate and it was difficult to get the pins lined up just right when getting the locks to seat in place. They were so difficult that I broke a few of the pin locks on my first attempt. And so, yeah, I just ordered new connectors from Mauser Electronics and started over. I was much more successful the second time. Please avoid the pain I went through and find a few videos to watch before attempting these. At least I have them all done now and tied up securely. It was frustrating, but I'm confident that they'll be reliable. The main power interface from the aircraft to the engine relay box uses a hefty amp connector with high current pins. To crimp the pins, I use my old reliable amp crimpers, which I'm sure are 40 years old by now. They haven't failed me yet. I cut the wire on my mark, then strip the end, making sure I get the wire through the right grommet hole. You can see how big these pins are, as they need to carry the full alternator current. Then with quite a bit of effort, crimp the pin onto the bare wire, with the second crimp on the insulation. Always giving it a security tug after each crimp. Once I had all the engine wires connected, it was finally time to energize the entire system, a milestone in the build. But first, I had to perform what we call a power and ground check. This ensures that when power is first applied, that at least the electrical power is going to the right places and each component is properly grounded. If these are wrong, smoke happens, and we don't want that. But if the signal or control wires are not going to the right pin, the system just doesn't work, far less critical than if power is going to the wrong pin. So even though I did ring out the entire system already, pin to pin, power was not applied. Different things happen when electrons are actually flowing through wires. As a cross wire may still ring out true when power is not applied, it then would cause all kinds of havoc when power is applied, possibly finding its way to a pin for signals, burning out that component. So it's very important to double check and ensure the power is going only to the intended place and each unit is properly grounded. And good thing that I did check, as I found a missing ground wire from the GPS antenna interface box to the single point ground terminal. It took some doing, but I finally found the culprit, a butt splice wire that pulled loose, no doubt when I was cinching up the harness around a tight bend behind the panel. This would have been a bear to troubleshoot after the boot cowl skin was on. Then it was time to populate the instrument panel and turn it all on for the first time. First was to make sure the G3X display fit in the panel without any interference, while the comm and transponder also fit in their panel racks properly, making sure the locks engaged correctly. Then with fingers crossed, we have life. Time to turn it all on. No smoke, always a good sign. A bench power supply substituted for the main chip battery, allowing me to keep an eye on how much current was being drawn. Then it was all about powering up the G3X in configuration mode. confirming all the units were talking to each other, and then just going through each menu to set up the parameters for the sensors and the discrete switch inputs. I made sure all the units are configured correctly, and also that the engine gauges are configured for the right side of the display, because that's where the engine controls are. Connecting the antenna and a headset allowed checking the full comm transceiver and intercom controls. I also checked the footwell lights and baggage lights to make sure they automatically turned off after 5 minutes. An important check was to ensure the G3X was talking to the engine computer. A quick movement of the throttle, which was reflected on the engine display, confirmed that connection. Then I temporarily connected the camera and landing light to test those. In addition, I temporarily installed the ELT, ensuring the GPS interface protocol was configured correctly, and also performed the pre-flight test. The USB port and cigarette lighter connections were checked, making sure that it really charges by phone. I haven't terminated the GPS antenna cable yet, but some clip leads allowed checking this vital receiver. The transponder was run through its built-in tests and limited configuration settings. I connected the antenna only to confirm its integrity, as the ground check will be performed by an Avionics shop with their specialized ADS-B test equipment. Then the last check was the communication to the magnetometer and autopilot pitch and roll servos. All looks good. Now that all the panel components are fitted and working, as much as I can tell at this point, the panel is ready to be labeled. I first built an Adobe Illustrator file of all the switch labels I'll need. I then had a friend who owns a sign shop print the individual labels onto adhesive back paper. An important step in the process was to ensure the surface was completely clean. Wiping down with alcohol works to remove any oils. Then it was just a matter of carefully placing each label with tweezers and burnishing it down to get the adhesive to set. I made multiple versions of the circuit breaker labels in case I need to reconfigure the power feed circuits. Those who know, know. Just kidding. The fuse block was to be mounted so as to be accessible through the cowling oil door, and the label identifies each position. And with the registration number in place, the airplane now has a name. I think the panel labels turned out pretty well. What do you think? Now that the fuselage work in my garage was complete, I loaded the truck and swapped the fuselage for the wings at the hangar. I had previously built up the wing structure, but hadn't covered them. This process was rather tedious, but I can highlight some of the more interesting things. First was, of course, to inspect the entire structure thoroughly, as I may never see parts of it again. Then all the surfaces needed to be scuffed up and cleaned with a solvent where the EcoBond glue would be applied. Then it was just about laying out the fabric and tacking down the edges. Applying the EcoBond through the fabric was the next step. Then there was lots and lots of ironing out of the fabric for a taut, smooth surface. This is the temperature probe for the air data system. The wire runs through a plastic conduit, and I had made a mounting plate on the wing underside. And just as a reminder, these always need to be mounted in the shade, preferably under a wing, because if they are mounted in direct sunlight, it would throw off their readings. The pitot tube needs to be mounted very securely, with a strong mounting plate, especially as this pitot tube is also going to be the angle of attack sensor. I had previously built a strong, gusseted plate that spanned across 2 ribs. The pitot mount, which I bought separately, is steel and sandwiches the mounting plate through the fabric. There are 3 plastic polyflow tubes routed through the wing. Pitot pressure and angle of attack pressure are temporarily sealed from dust and identified with black and red tape. The 3rd tube is a spare, tied back with a white tip. I really don't want to tear the wing apart if a tube springs a leak down the road. When making all the reinforcement patches, what we affectionately call doilies, It's wise to soak the fabric in diluted EcoBond where the edges are to be cut with pinking shears. It keeps the edges from fraying and makes for a very smooth and clean edge when finished. I had to redo the magnetometer access plate mounting fasteners, as further research realized that the stainless steel anchors I originally used may become magnetic over time, so I needed to replace those with aluminum riv nuts, which protrude a little from the surface. It took a little work, but I was able to seal the fabric around these and wrap the fabric around the large opening. The fabric was then glued around the edge and tacked down with heat. The ribs are secured to the fabric with rivets after a plastic strip is held down with double-back sticky tape. A soldering iron is used to make the rivet holes through the plastic strip. And of course, having a rotisserie greatly helps the process. Keeping the tape line straight definitely took a little effort. It's harder than it looks, especially as the EcoBond glue is very slippery before it's dry. I think they turned out pretty good, but we won't tell how good until after it's painted. Fingers crossed. Then when the fabric work was complete, it was time to cocoon them again in plastic for storage in the incredibly dusty hangar. Finishing up the wings was the absolute last thing I could do in my garage, so I packed them up and brought them over to the hangar along with all the parts, tools, and supplies. I have a proper garage at home now, so once again I can park both cars. It's been a few years. Now I just need to figure out how I'm going to paint this thing.